Welcome to myprojectbizard.com. Our project title is Efficient Prediction of Difficult Keyword Queries over Databases. And the modified title is Resourceful Prophecy of Difficult Keyword Queries over the Records. Our contribution is to keyword queries on database provide easy access to data but often suffer from low ranking quality, that is low precision or low recall. In recent benchmarks which are shown as a low ranking quality, it will be useful to identify queries that are likely to have low ranking quality. To improve the user satisfaction, the system may suggest to the user alternative queries for such hard queries. In this, we propose to analyze the characteristics of hard queries and propose a novel framework to measure the degree of difficulty for a keyword query over a database. Considering both the structure and the content of databases, and the query results are evaluated on the basis of user's query definition. We evaluate our query difficulty prediction model against two effectiveness benchmarks for popular keyword searching ranking methods. Our empirical result shows our model predicts the hard queries with high accuracy and low time complexity. Further, we provide optimizations to minimize the time overhead. It should be done systematically and with either minimal or no human intervention depending on the model. During automatic keyword extraction from multiple party dialogue episodes, the advantage of using the lexical resources are compared to a pure statistical method and the relative frequency ratio. It models the database as a directed graph where the tuples are the weighted nodes and the foreign key relationships between the tuples are the directed edges. Employed statistical method about the database content to create the lexical resources to a pure statistical method, and analyzing the alternative query ranking factors increase the effectiveness and efficiency of the query search related to the user's definition. Now the flow of the process. Initially load the dataset. The dataset like movie dataset or user defined dataset or any other rating dataset. These dataset are undergoes on processing data. If the query is extracted based on the user given keyword is correct, it goes through the further process. Otherwise, it process get aborted. If the query is extracted and the user's definitions is valid, list of results based on query will be given, and the corrupted list are updated into the corrupted list, generate the re-ranked list. Then evaluated the SQL score and evaluate the performance which are based on the user's query request with find outing the difficult keyword query search. The corrupted query list means which is calculated on the basis of user's given query, and that particular results extracted particular results are updated on the corruption list, and again the list are re-ranked. Then based on that re-ranked list we can evaluate the score ranking and evaluate the performance. SER scores are evaluated on the basis of precision and recall values from the basis of the original dataset and the corrupted updated dataset. Corrupted updated results are nothing but the query evaluated on the basis of the user and the list of results. Based on this, we can evaluate the SR score. Otherwise, the query is not based on the user's definitions or the keyword. The process get aborted. The overall process get terminated on that process. Otherwise, if it is possible to find out the keywords, we can calculate the performances and the search values. Now the demo of the process. Right click on home.java and select run file. Click browse button to select the dataset. Select the dataset. The dataset is a national relation root database. Click open. Then click view. The selected dataset are loaded unsuccessfully. The number of instances and number of attributes are shown here. Then click next button. Databases are created automatically based on the dataset name. Click create database. The database is created as the dataset name. Load database into the dataset. The processing ongoing on. Successfully loaded to the database. Then view the database content. Viewing the database. Then click next. Search query. Given the user defined query. Click remove button and parts. The one item can be parsed out. Then click next button. Click retrieve. The query related searches are retrieved here. Then click next button. Avoid repetitions. Compute. Similarity measures are calculated here. Then view the similarity results number. View the measurement ranks between the requested query. Then click next. Click retrieve values. Enter the k values, which is the definitions values too. Click OK. Click next button, which shows the recall values by precision based on the score ranking on the basis of algorithm. The algorithm and the corresponding recall values are evaluated here. In this, precision values are evaluated can be calculated over the algorithm. Recall values are calculated for the exceptions of the overall dataset which are initially stored in the database. The stored database and the currently evaluated, that means the corrupted list of the re-ranked datasets, compared each other with the original dataset, and the corrupted datasets are calculated on the matchings. We can calculate the recall, which shows the corrected words and then the normal words between the dataset. The dataset is the score of the overall databases. Then the recall values are calculated from the initial dataset and the ranked dataset. And the both precision values are calculated in the sections of the recall values and the number of corrected values that can be calculated on the overall algorithm. And the precisions, that precision values are evaluated on the corrupted list, that the re-ranked list. The algorithms are calculated, the both are evaluated on the basis of a algorithm comparison. Algorithms are calculated using the recall and the precision are using on the basis of precision, that the algorithm is nothing but the SQR score values. Thank you.